Hi, so in this video I just want to go over solving trig equations. So I'm going to solve a very basic one, number 1, and then one where there's a double angle, number 5, and then we'll go over number 15, which is where we need to find all solutions in radians. So feel free to pause, fast forward, or rewind so that you can focus on whichever section you need to. So just very basically, let's just go over number 1. So number 1, we have cosine of theta equals 1/2. So my trig function is already isolated, and so the next thing I should notice is what quadrant it's in. And we know cosine is positive in quadrant 1 and quadrant 4. So the next thing would be to find my reference angle, and so that's by taking the inverse of the positive value of this answer, and we know that gives us our reference angle. But without a calculator even, I know cosine is 1/2 when my reference angle is 60 degrees. But I want to talk about a general solution. Even though they're telling me to solve for theta between 0 and 360, they're being very specific. It's within this interval. I know cosine is defined for all real numbers, so this goes on and on to infinity. So really there's an infinite amount of solutions. So what are those infinite amount of solutions? Well, I know that theta can, if it's 60 degrees, well, I'll get back to that position if I keep adding 360 degrees, right? I'll just go full time around right back to this spot where it's 60 degrees. And so this is my general solution. And if I'm in quadrant 4, well then again, if my reference angle is 60, then my angle is 360 minus 60, which is 300 degrees. And if I keep adding 360 to that, I'll get multiple angles that end up in the same position. So these are my general solutions to this problem. But since they specifically wanted theta between 0 and 360 degrees, again, when n is 0, I'm only 60 degrees. When n is 0, then it's just 300 degrees. And so final answer. Okay, so now let's look at problem number 5. Number 5 is different because now it's not just theta, but we have cotangent of 2 theta equals radical 3 over 3. Okay, so again, my trig function is isolated, so I know this is cotangent and it's positive, so I must be in quadrant 1. And since cotangent is the reciprocal of tangent, I'm also positive in quadrant 3. So next thing is, well, 2 theta, remember 2, it's right before my theta. What does this mean? This is my frequency. And if my frequency is 2, that means I have 2 cycles happening in a period of 2 pi. So I know if it was just cosine theta, I would have 2 answers. Chances are, if this is happening twice in 2 pi, well then I probably have, or I must have, 4 solutions. So let's see how to solve this. First off, why don't we let u equal 2 theta? Because now if I replace the 2 theta with u, this looks like a problem that I know how to solve. But it is one of my reciprocal functions, and I don't have a cotangent button, so if cotan of u is radical 3 over 3, then tangent of u must be 3 over radical 3. And now at this point, I can find my reference angle. And we find that by doing tan inverse 1 of 3 radical 3. 3 radical 3. What does that equal? If we have a calculator, you can figure that out. Or if I just rationalize this, I get 3 radical 3 over 3, which equals radical 3. I know when tangent is radical 3 at 60 degrees. Okay. So I have my reference angle. So now we'll talk about general solutions again. If I'm in quadrant 1, then I know it's 60 degrees plus 360 degrees n. If I'm in quadrant 3, then I know it's, so my reference angle is 60, 180 plus 60, we have 240 degrees plus 360 degrees n. But remember, this is what u equals, and what is u? U is 2 theta. So 2 theta is what equals this general solution. 2 theta is the answer to this general solution. But I don't want 2 theta, I just want theta, so I'll divide everything by 2. Divide everything by 2. So I get theta equals 60 divided by 2, I get 30 degrees plus 180 degrees n. And here I will get 120 degrees plus 180 degrees n. So now I need to find my solutions within, remember theta has to be within 0 and 360. This is where we're looking for theta. So first let n equals 0, and so then I just have my 30 degrees. Now if n is 1, well then I have 180 plus 30, and that will give me 210 degrees. If n is 2, well that makes this 360 plus, I'm already out of this range, so I'm finished with using this general form. Now let's try this general form. Okay, so when n is 0, I have 120 degrees. And now when n is 1, well 180 plus 120 gives me 300 degrees. And that's still within this range. N is 2 makes this 360. I'm already over, so here are my final solutions. And look at that, 1, 2, 3, 4, just what I expected to have. 4 solutions. Okay, number 15. I have to talk about this fast because the bell is going to ring. I have secant of 3 theta equals 2. Okay, so again, we need to isolate my trig function, so I'll subtract 4. And I get secant of 3 theta equals negative 2. So I can look at this, but I don't like secant. I know secant is the reciprocal of cosine. So cosine of 3 theta must be the reciprocal of this. I get negative 1/2. Identify my quadrants. Cosine is negative in 2 and in quadrant 3. I'm going to let u equal 3 theta. So therefore cosine of u equals negative 1/2. So again, to find my reference angle, I'll do cos inverse of the positive value to get my reference angle. But I know cosine is 1/2 when theta equals 60 degrees, but the directions here say radians, so I'm going to write 60 degrees as pi over 3. And so general solution for quadrant 2, since this is only asking for general solution. So I know in quadrant 2, I know I have to take my reference angle plus pi. So I have pi plus my reference angle. And so I have, quadrant 2. It's pi minus my reference angle. So 3 pi over 3 minus pi over 3. I have 2 pi over 3. Plus, well not 360 since we're talking about radians, 2 pi n. And in quadrant 3, this is where I take pi plus my reference angle. And so here I get 4 pi over 3 plus 2 pi n. This is what u equals, but we know u is 3 theta. 3 theta. And so I need to divide everything by 3, which is the same as multiplying everything by 1/3. And so I have theta equals, if I'm multiplying this by 1/3, I have 2 pi over 9 plus 2 pi over 3n. And here I have theta equals 4 pi over 9 plus 2 pi over 3n. And since it's asking for all solutions, I'm going to leave my answer.